So a function is injective or one-to-one, so these two terms are synonymous to each other. Okay? Injective, if for every pair of numbers x1 different than x2, we have f of x1 is different than f of x2. Okay? So if a function is injective, then the equation y equals f of x has either no solution or a unique solution. So what does this mean? So suppose I have this value x1 and then this value x2. What I'm saying is if a function is injective, I can't have the same value here, f of x1, and the same value here, f of x2. Okay? So these two values have to be different. That's what injective means. Okay? And so that means that, you know, for every x, I get a unique f of x, and so I can get back to x from f of x so very quickly, right? And this inverse of operation is what we call the inverse of f, and we will see that later on in this unit. So it's like unique mapping from x to f of x. Okay, so it's mapping the domain to a unique set and then going back. Okay, so for instance, let's see if I have a line, you know, f of x is a times x, where a is a real number, then this function is injective. Okay, if you take any value here, x, well, this is mapped to a times x, and a times x, the only time that the function takes the value a times x is when you use x as an input, right? But again, if you have x squared, this is not true. So for instance, if I have this value x squared, okay, in this case, well, there are two values that give me the same value x squared. You have x and you have minus x, okay? So two possible inputs gives you the same output from f. Okay, so you couldn't go back to one x, you would go back to two different x's when you do this operation. Okay, so this equation y is equal to f of x. In injective functions, you have only one solution if there is a solution. Okay, in functions that are not injective, you could have more than one solution. Okay, so if I say y is equal to x squared, there are two solutions for that equation, right? So now a function is surjective, okay, similar term, surjective or onto, okay, again synonymous, surjective onto, if the if the image of the function, the range of the function is the reals. Okay, if a function is surjective, then the equation y equals f of x always has at least one solution. Okay, so what is this saying? Well, that functions like this, like again, x, f of x is a times x. The range of it, so if you look at the vertical values that the function is taking, it takes every single value from minus infinity to infinity. Okay. So that means that when I write this equation, y is equal to f of x, so for instance y is equal to a times x, there is always, it doesn't matter which value of y I choose, there is always an x that gives me this y, right? At least one. Now, if I have a function again like x squared, okay, if I write this function, this equation y is equal to x squared, there is not always a solution for this equation. If I choose, for instance, y is minus a, so negative number, then there is no x that gives me this as a solution. Okay, there's no way that I can square something and get something negative. So in graphical terms, you have this negative part of the y-axis is not mapped by any value of x, right? Again, so that the image of x squared is close 0 to infinity, right? So it's not the reals. And finally, a function is bijective is if it is injective and surjective at the same time. Okay, so for instance, f of x equals a times x, it's bijective. Okay, and x squared is neither injective nor surjective, so it cannot be bijective. Okay? So if a function is bijective, the equation y equals f of x always has one and only one solution for each y in the real line. Okay, so what these bijective functions are doing is for every x, I'm getting a y, so y is f of x, and only one. Okay, so I'm mapping the real line to a different thing. Okay, so for instance here in the line, okay, a times x. So it's kind of a unique mapping for every x in the line, every x to every y. Okay, so it transforms the real line into a different version of itself.